Here are the solutions to problems 10 and 11 on the equilibrium problem paper. Number 10, we have an object that's hanging from a rope. You can see that here in pink. We're trying to find that tension. There's another rope that's going directly to the right into this wall. We can see that's drawn here in blue. That's called T2, and force of gravity pulls straight down. This one force that's at an angle, I am going to have to break into its components. I'm pulling that. This rope is pulling some up, which is why it's up off the ground, and it's also pulling some to the left. I'm going to break these into its components, solving for those. Tension in the x is the opposite side of this particular triangle, so I'm going to use the sine of 30 degrees multiplied by the hypotenuse, which is tension. The y is the adjacent side of this triangle, so cosine of 30 degrees multiplied by the hypotenuse is how I would solve for t in the y direction. Once I've done that and I've broken it into my ty and my tx, I'm going to redraw this problem here because it's kind of messy. I've got a triangle and some angles. It's a little bit ugly. So if I redraw this here, I'm going to have force of gravity down. You see that right here. I'm going to have this tension to the right. Here's T2. And instead of having this triangle, I'm only going to draw Ty, that's straight up, and this Tx, that's directly to the left. So I really only have one up, one down, one right, and one left force. If I take a look at my up and down stuff first, I know Ty is up, force of gravity is down, and because there's no acceleration, my up stuff has to equal my down stuff. So Ty equals force of gravity. Ty is the cosine of 30 times the t, so cosine of 30 times t equals force of gravity, which is mg. I can divide by cosine of 30, giving me mg over cosine 30. So 5 times 9.8 over the cosine of 30 tells me that T1 has to equal 56.6 newtons. Going right and left, here I have T2 equals t in the x direction, because right stuff has to equal left stuff, because again, no acceleration. So T2 has to equal t in the x direction. Well, I know t in the x direction right here is sine of 30 times T1. We just solved for T1. It's 56.6. So that means T2 equals sine of 30 times 56.6, which tells me that T2 is 28.3 newtons. Number 11 is probably the most challenging one here on the paper. These two angles are not the same, so these two tensions, T1 and T2, will not be identical. Here we go. The only mass that we know right off the bat is the 20 kilogram mass all the way to the right. And we can solve for some information here. That's going to be called mass 1, because here's mass 2, here's mass 3. If I don't worry about any of this stuff over here, just focus on this guy, I have T1 up and force of gravity down. We know our up stuff has to equal our down stuff, so this tension up has to equal this force of gravity down. Here we have that, T1 equals force of gravity, and we know this mass is 20 times 9.8, tells us that this rope here that goes from M3 over this pulley and down to this 20 kilogram mass, this tension here must be 196, because T1 has to equal the weight of this 20 kilogram mass. Well, now if we go to this M3, I know that this T1 equals 196, because that's what I just solved for. Because I know this is 196 and I know this angle, I can solve for this T1 in the y, and I can solve for this T1 in the x. So I know how much this rope, and only this rope, is pulling to the right, and I know how much it's pulling up, because I can do a little sine and cosine and find that information out. Here it is right here. T1 in the y is cosine of 30, because it's the adjacent side, times this T1. And if we want to plug in, we could find out that that's the cosine of 30 times 196. T1 in the x direction is the opposite side, so that's going to be sine of 30 times T1, which is 196. So now if I look at mass 3 and I look at left and right, I know that this T1 in the x has to equal this T2 in the x, because for M3, it's being pulled to the right here, it's being pulled to the left there, and they must be equal to each other. So T1 in the x equals T2 in the x. Well, we already said that T2 in the x is sine of 50 times T2. T1 in the x, because it's the opposite side of this triangle, is also found by sine of 50 degrees times this T2, which we don't happen to know. So sine of 30 T1 equals sine of 50 T2. If I solve for T2, because again we know T1 is 196, just divide by sine of 50. So sine of 30 times 196 divided by sine of 50 tells me that this tension right here has to be 127.9 newtons. In the up and the down, T2 in the y and T1 in the y, both are going upward. They have to equal the force of gravity down. So T1y plus T2y equals force of gravity down. T1y is the cosine of 30 times T1. T2y is cosine of 50 times T2. Again, these are all found right here. It's just these components of this triangle and this triangle. A little bit of algebra later if I'm trying to solve for mass 3, because I can solve for all of the tensions because I know T2 and I know T1, and I'm able to plug in some of my numbers here and get that the mass of that big middle object is 25.7 kilograms. Finally, over here for M2, I know T2 because I solved it earlier when I was doing mass 3's right and left is 127.9. So I know this upward force has to be 127.9. So I know this force of gravity has to be 127.9. Because again, up equals down. So T2, 127.9 equals mg, divide by g, which is 9.8. So 127.9 divided by 9.8 tells me that this M2 mass is 13.05 kilograms.